Wowie zowie. Give me just a second. We're almost done. Almost set up. I'm trying to get everything set up before stream starts, but c'est la vide. Hi, YouTube. Okay, so today, let me just link a few things here and we'll get started on today. Today, we're going to be doing more OpenGL, but we're not setting anything up. It's all linked this time. It's all there. It's all good in the neighborhood. All right. Okay. All right. Okay. Avitas and goodbye. Let me just get a few things linked here. Click. Loot. Or mute. Not loot. Not mute. Sorry, we had a Path of Exile discussion earlier. Aphrodite, hello! Welcome to the 3D development stream where we're drawing triangles and shit. What are we listening to today? Lo-Fi Leah? It's been a long time since I listened to Lo-Fi Leah. Oh, vibes. All right, minimize, shrink, move over here. Okay, let's get started. So we're skipping the whole beginning of learning OpenGL and everything. We don't need to go that far. We already know it. So, well, we already know the beginning of it. Wait, did I save the fucking book? Oh yeah, no, it's learn OpenGL. We're good. This is not the right thing. Hold on. That was not the right program. OpenGL tutorial. There we go. Okay, so this is our OpenGL tutorial. We currently have this as our setup here. You ready? Get ready. Purple screen. But here's the good news. This is not drawn in SDL. This is not the 2D STL library we were doing before. This is OpenGL, which communicates with our graphics card and is the basis for our 3D environment we are going to be making. WWDC24. That sounds like a wrestling event. So yeah, this is our program, and then we click to close out of it. That's what this is for. Okay, we're gonna start the next tutorial. It's gonna be great. OpenGL learn OpenGL book.pdf. Okay. Boop. If you guys want to follow along, this is the tutorial we're going to be using. Paste. So this is what we're going to be following. This is actually the same textbook well, when I take computer graphics, one of the 4 required readings. This is just one of them. And we're going to be doing this together. Currently, we are on, I believe, not extensions. We're past that. Not the state machine. We already know about that. Developers, Apple. What's this? Oh, I don't care. Oh, that's, yeah, pass. Sorry. I know the proper streaming thing is just to, like react to like modern things that happened in the last day or two. I don't care. I'm not one of those people. I'm not going to be a professional streamer. I'm doing this to learn. You know, we're learning together. Oh, I love this song. It's also copyrighted, and I can play it on the piano. Skip. Neon Genesis Evangelion. Fly me to the moon. Okay. OpenGL library on Linux. GLAD. We're not doing GLAD. We're doing SDL in this case. We're going to do GLAD later. Okay, I think we're ready for Hello Windows. So we already have, ooh, that's new. No, this is the context for the other library, so we're good here. This is Windows null, failed to create window, so that's separate from what we're doing. So a viewport, we have to tell OpenGL the size of the rendering window so OpenGL knows how we want to display the data and coordinates. So it's interesting how we have to have a viewport every frame. That's new to me. In SDL, you just had one renderer. You could have viewports, but it was really much intended to be like a one renderer fits all situations. Like this is always the size of the SDL renderer. So it's interesting that we do have dedicated viewports where even like the initial rendering in Hello World version has a viewport. So that's just interesting to me. If you guys don't know viewports, let me draw this real quick if you guys are new to this. in rendering land, if this is your game, let's say this is your game and you have this, what's like a good example? Let's say this is your game and you have a little 3D guy here and he's like, ooh, there's our little 3D guy, right? With our 3rd grade shoulders, right? And you're like facing that way, okay? Let's say this is a 3D environment, so you have like, ooh, building here, all that good stuff, right? Well, this is what a viewport is. A viewport is if this is your mini-map. You know that'll be your mini-map. That is never changing where it's going. So what you can do is you can have a dedicated viewport that's only in this area, and it just deals with the mini-map. This is for performance reasons, in addition to, well, more than anything else, it just organizes you, you know? Like if you always have like this area as like your health and stamina bar or something, or like, I don't know, the main character is always here, then you can just save yourself resources and just mind share by like always having the viewport or the resolution be like one, or the graphic always being one part of the thing, your UI elements and all that. That's like an example of a viewport. So if, for example, in, what's a good example? Heroes of Might and Magic 3, this part of the screen was like minimap, text, character, text. This was always there. You couldn't move that. I don't even know if a mod can move that, probably. But like this is like the renderer, that's a viewport. I'll guarantee you without knowing anything about the programming of the game. But like that's what I mean by viewport. So in this case, we have a viewport for the entire screen. That's what was throwing me off. This, because I'm not used to that. An SDL, a viewport is like a dedicated thing versus the renderer in general. So what is it? First 2 parameters set the X and Y. Oh, the first 2 parameters of the viewport set the location in the lower left corner of the window. Okay, for those of you OpenGL weebs, before we get started, is that how every rectangle in OpenGL works? Is every rectangle bottom left starting? That's super weird to me. Like in video game engine land, in all of my experience, it's always been the XY value is in the top left and increases in the Y value goes down. So if that's how it is for everything, that's gonna be super backwards for me and I'm gonna fuck something up. Code Toil. Oh, I was pinned? Pinned by Gary the Goo Boy. How are you pinned? How did you even do that? How do you even get pinned? I don't even know what button I press. Also, Sleepy Mushroom, hello. Okay, so you could actually set the viewport dimensions at values smaller than the dimensions of the window. Then all of OpenGL's rendering would be displayed in a smaller window, and we could, for example, display other elements outside of the viewport. So that's an example of that. It's just, it's performance and it's organization. I do like using viewports a lot in my experience. I like having the, you know, if anything deals with the minimap, I go to the minimap rendering viewport. If there's anything dealing with like the game, it's like, oh, the whole window viewport. I really like that. X0, Y0 is the middle of the screen. It's a float range from -1 to 1. Is that, I mean, if I made a video game engine, I definitely wouldn't make XO, YO the middle of the screen. That seems very mistake prone. I would rather have like it in one corner in whatever quadrant we're in, just have it in a corner so you can just base it all off that. You must have done something? I don't know, maybe. Moldrum, hello. How's everyone doing today? How's everyone, how are Kit Kats doing? Yesterday I was busy, but oh, I hope you guys are doing well. Behind the scenes, OpenGL uses by the way, we're gonna read this little behind the scenes stuff because, sorry, zoom in there for you, because I'm gonna have to learn it because I'm in college. I gotta learn this stuff. Hello Triangle will look crazy the first time you see it. Well, we're about to find out. Not Human. Hello, Not Human. How's it been? It's been a couple days. Behind the scenes, OpenGL uses the data specified via the viewport, which is the whole window right now, to transform the 2D coordinates it processed into coordinates on your screen. For example, a processed point of location -0.5 would, as its final transformation, be mapped to 200, 450 in screen coordinates. Note that processed coordinates in OpenGL are between -1 and 1, so we effectively map from the range -1 to 1 to 0800 and 0600. Oh, I know exactly why it does that too. It does that because these resolutions is how we set up the first window. I did 400 by 400. That's why it looks like this in the corner. That's why it's really small, right? Because I knew it was going to be a funky color, so I didn't want to be like huge. This is our 400 by 400 window. So what you're telling me is that in OpenGL land, yes, Muldrum, I did change it. The resolution they specified was 800 by 600. So as far as I know, in between chat and the book, in OpenGL land, what it does is whatever it does on its end, the result will be the following. The very center point in OpenGL land before it gets translated to R2D coordinates is 0, 0. To go all the way to the left is -0.5. To go all the way to the... I lied. To go all the way to the left is -1. To go all the way to the right is 1. To go all the way to the bottom is y -1. And to go all the way to the top is y1, right? X, Y, Cartesian plane, all that good stuff, right? However, when you actually translate that into our coordinates on the screen, it's not a 1 by 1 pixel. It actually does the favor for us, translating it into like resolution terms. So if I specified like -0.5.5, it would go, okay, well, you want to go here, and then you want to go up, so you're right here. But it's going to be in translated land 100 by 100, right? Because this is a 400 by 400 square box. It's going to be 100 to the right, 100 down. So that's where that resolution is. Okay. I understand. Okay, I get it. That's simple. Now that I know that, that's simple. This is a good book so far. However, the moment the user resizes the window, the viewport should be adjusted as well. We can register a callback function on the window that gets called each time the window is resized. This resize callback function has the following prototype. Void frame buffer size callback the window we're in, int width, int height. The frame buffer size function takes the window as its first argument in integers. Okay, so we're gonna make this function. And then it calls this viewport. Okay. We have to tell it we want to call this function on every window resize by registering it. Set frame buffer size callback. Okay. Okay, so we have to translate this into SDL terms, right? So we need a function, frame buffer size callback. So that doesn't exist, I'm assuming. Frame, oh, wait, what? Frame, hold on, GL, frame buffer size. Yeah, okay. So we're gonna make a function. All right, so it's telling me auto frame buffer size callback, and as a parameter we're going to be needing what are we needing? We need a SDL window pointer window. We need a int width and int height. So I think it comes in the struct, right? In fact, it's everything here. Hold on, this is just all this except without the context, which is this, the OpenGL context we're in right now. The context is the state that we update every frame. Okay, okay. So that's going to be those three we call. Now with those three, we do have it set at const right now. We should back out of, well, no, fuck it. We'll keep it as const. But that means we got a resizable. Hold on. Window resizable. There. So we'll take off the const so that way it's not, so we can actually change it. I think if I don't, it's gonna cause like a crash or something. And then it's gonna return, I'm assuming void. Copy. We had to prototype it, so that's where this is coming from. Previously given window size. I thought it was old enough that it was our monitor size. Oh, no, 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 no. I hope not. You could avoid all of that by just making the screen width height to the width height of the function parameters. Yeah, isn't that what we're doing? Const ain't the right call. It doesn't crash. Oh, it's just const isn't the right call there. Okay. I guess not anyway, right? Because it changes all the time. Okay, so then all we're gonna do is just call that viewport we did before. Copy, paste, and then it's not gonna return anything, right? Yeah, it's a void function. Okay, so now we're just gonna call this function. Do we call this every frame? That's not wise, right? It's only when we resize the frame. How do I set up that event? When the window is first displayed, frame buffer size callback gets called as well with the resulting window dimensions. For retina displays, width and height will end up significantly higher than the original input values. There are many callback functions we can set to register our own functions. For example, we can make a callback function to process joystick input functions, process error messages, etc. We register the callback functions after we've created the window and before the render loop is initiated. So we haven't called it yet, right? So that's the viewport. So... Oh, so we're getting rid of this. Gotcha. So now we just call frame buffer size callback using window screen width screen height. Is this really what we're doing? This doesn't feel right. Oh, that worked. Never mind. Oh, well, shit. It's the same thing as if we're basically calling it no matter what. But okay, I can vibe with that. Cool. Okay. It's kind of bugged. Well, I think it's more of an issue of us not allowing the program to run outside of the context of our mouse being in the game. That might be part of it. Because when I had my SDL games, the game engine always paused when the mouse wasn't highlighting the game. So it did the exact same thing there too. I think if we let the logic run inside of the game, even whether or not the mouse was in the window, it would be fixed. Well, I guess I could try it. There's a flag for this, right? What's the word for it? SDL mouse. What am I looking for? It's not locking the mouse, but I'm looking for if the mouse isn't in the screen, we still run the game. SDL flags window. Let's see here. OpenGL, shown, hidden, borderless, resizable, minimize, maximize, mouse grabbed, window input focus. So what's the opposite of window input or mouse focus? Allow high DPI, foreign, mouse capture, always on top. Is that what it is? Keyboard grabbed, tooltip utility, skip taskbar. Let's try Windows always on top. Ah, never mind. I'm an idiot. That just does what it says on the tin. It literally just puts the window on top of everything. Okay. Kind of cute. That'd be good for like application stuff, just not for video games. Interesting. Okay. I wouldn't recommend putting the set frame in the render loop. It gets really funky when you start making stuff. Well, I would imagine we would set up some event where it's like if the screen width changes value at all. I guess we could try that. Oh, no, wait. Wait, we don't want this here. We want to run this before, right? Also, I'm rearranging this horribly. Hold on. We want to set this up like before we do anything. Right? So now, if I resize it, nothing updates. Oh God, how did it update? Wait, how? No, it's not updating. No, I get it. It's a context. Oh, you're right, Sleepy Mushroom. I get it. I get it. Okay. Because I fucked up and I left it in the render loop. Okay, hold on. If I know this right, I'm gonna say, okay, play, resize. Okay, I know why this is all purple. I know why. Because in OpenGL land, nothing changes. You still have your like context that you still have everything, right? The only difference is that now the translation, remember how I said 400 by 400? Well, it's the logic is still there. It's draw the screen purple, -1 to 1, -1 to 1, right? The whole screen. All we're giving it is different like resolutions to render to. We're not updating we're not doing the frame buffer thing. All we're doing is just resizing the output that OpenGL renders to. I didn't realize that would be the case. Am I doing this right? Am I like interpreting this correctly? Even though we're not updating or buffer whatever we're doing every frame, which we're not, it's still updating because of how OpenGL renders like the context. Okay, that makes more sense to me. Next. It should not be in the render loop. Yeah. I got you. So what you're saying is this. Oh, wait, hold on. Let me understand this. Should this frame buffer size callback only be called every time we resize the resolution? Or should it be only established once and then don't touch it? Does that make sense? Or whenever you change the resolution of the screen, basically. I don't know. Is it like a one time and you're done? Established once. Okay, if it's established once, why do we have, I guess maybe there's more to it. I guess why don't you just call the viewport and that's it? Okay, I got you. Thank you, Sleepy Mush. I'm glad you know your shit. Okay, we'll keep our window flags here just in case. We might need some of this here. Nah, it needs to be updated. Oh, it does need to be updated every resolution change? Okay, so it would be something like, assuming there's not already a function for it, it'd be like, I'm assuming you would do the callback before you would do your rendering, so it'd be the first thing you do. So it'd be like if, I guess you'd have like an int screen width temp. That seems obnoxious. I guess I could though. Int temp screen width equals screen width. You would do that up here, right? That seems obnoxious. I'd recommend putting it where you're making the window. Well, that's what these are, right? So we have our initialization, and this is our SDL window, our local rect. So these are the 400 by 400 values. We're actually putting that in a struct called app info. App info has the width and height of the screen. then we hop over to our CPP file. We actually, as part of the game loop function, call the width and height of app data, which is now screen width, screen height. So that is the width and height of the screen. So that's what we're sending into here. So that's why it's updating every time. Yeah. So I don't know if we need like some temp value so we can compare against it. I don't know how you would call that, or if we could probably just set up some event. We'll see. Frame buffer size callback. There are many callback functions we can set to register our own functions. For example, we can make a callback function that processes joystick input changes, process error messages, etc. We register the callback functions after we've created the window before the render loop is initiated. Gotcha. Okay. Can I post a link for an example from SO? Yeah, go for it. Listen, you can backseat program me all you want. You can backseat game me, but you can't get mad if I don't listen to you. Those are the rules. Ready your engines. We don't want the application to draw a single image and then immediately quit and close the window, which we don't because I already account for a loop. We want the application to keep drawing images and handling user input until the program has been explicitly told to stop. For this reason, we have created a while loop, and then we can now call the render loop, which keeps running until we just, okay, we've already done this. Yeah, poll events, yeah. So GLAFW, which is what the book uses, it looks like it just does poll events, swap buffers, window, all that stuff. In SDL, it's just clear color, clear, swap window. So we've already done that. Bless SDL for already implementing OpenGL functions. Did I need to import anything? Yeah, it's import SDL, OpenGL. Dude, SDL is like the greatest library you could ever ask for. It's so good. No pool events? No, we have a pool event. It's poll event here. So we have our SDL poll event, grabbing the input event. If it's not equal to 0, meaning that there's something in there, then grab the input event type. If it's equal to mouse button down, then quit the program. That's basically all we're doing right now, but we do already have our poll events. So that means we can run our program. Oh, nothing's happening, but it's constantly refreshing like 2,000 times a second, and click, closes. That's all we're doing so far. Windows should close function checks start of each loop if the iteration has been instructed to close. If so, the function returns true and the render loop stops running, after which we close the application, which we did. Swap the color buffer, we already did that. A large 2D buffer that contains color values for each pixel in the window. Yep. Double buffer. When an application draws a single buffer, the resulting image may display flickering issues. This is because the resulting output image is not drawn in an instant, but drawn pixel by pixel and usually from left to right and top to bottom. Because this image is not displayed at an instant to the user while it's still being rendered to, the result may contain artifacts. To circumvent these issues, windowing applications may apply a double buffer for rendering. The front buffer contains a final output image that is shown as the screen, while the rendering commands draw to the back buffer. As soon as all the rendering commands are finished, we swap the back buffer and the front buffer so the image can be displayed while still being rendered to, removing all the aforementioned artifacts. We already do that! That's exactly what we've already done. Color clear, clear, swap window. So we've already accounted for that. It works the exact same way with our 2D SDL game. So we've already learned this lesson in our own game engines. Let's get a triangle on the screen. Also get a gloof terminate. We'll get there. OpenGL is a state machine. You'll learn why it's going to bite you. Well, it hasn't bitten me yet. If anything, it's a cute little dog that I'm petting right now. One last thing, as soon as we exit the render loop, we would like to properly clean all of the resources we were allocated. We can do this via terminate function. We call it the end of the main function. Oh, we need to do this ourselves. Hold on. That's actually kind of important, isn't it? For now, we'll just make this our own function. So we'll just call this close, I don't know, open terminate resources. I don't know what to call it. Terminate SDL close. That's what we'll call it. Fuck it. It's called close. And it's going to return Nothing. Ooh, do we have an object? I kind of, oh man, this is where my object-oriented brain is like coming in. I kind of want to make like an object that can auto-terminate itself. Fuck it. SDL, window, and that's all. Oh, and then we need an OpenGL context, which is GL context. SDL GL context. Okay, gotta remember that. Context. And then I think that's all we're deleting right now. So that's gonna return void. Okay, so the window dot fuck. SDL delete window. SDL window. Fuck, I forgot what it's called. SDL, was it remove window? Delete window? Set? Get? Create? Destroy! That's what it was. Window. And then probably SDL, GL, remove. Release flag. Delete context. Context. I'm assuming that's how that works. Probably call that by reference. That'll work, right? And before we do it, we close. What are you doing, fam? We're just cleaning up. So at the end of the program, rather than doing what's based, which is letting your operating system handle the garbage collection, we're explicitly deleting everything we need to here. GL context. There we go. And now whenever we close the program, we delete the window and the context, and it's super clean. Okay. That's all we're doing. We're just kind of doing what he's doing here. Just instead of calling terminate, whatever that is, which probably cleans up all your resources, SDL's a little more pedantic. Oh, he wants a black screen. Okay, I can do that. All we have to do is just change this to 0, 0, and black screen. We did it. Whoa, look at that. You know what? We need something a little fancier. Sleepy Mush, you're question marking me. What are you confused about? Color wheel. I want to get my color. 1 second. All I'm looking for is just my color. That's all I'm looking for. It's just my color. My color. Pick color RGB. There we go. There. Perfect. Okay. These numbers. And then dot F, dot F, dot F. Let's quickly make this 800 by 800. And if everything worked, why is that white? That shouldn't be white. 255 is perfectly transparent, right? Yeah. Why is that white? That shouldn't be white. When you create a window without clearing the buffer, it's automatically black? Don't we clear that though? That's what we do right here. GL clear, GL color buffer bit. Isn't that automatically what we do? The range is 0 to 1, not 0 to 255. Oh, you bitch. You're right. Hold on. I can fix this. I can fix everything. Shit. Oh my God, you're totally right. Okay. So let's do it in like, so this is like 0.2. This is 0.6. This is 0.55. I think I did that right. Ow, chat. God, I'm good. Bit of a hack, but it works. Yeah, divide 255 into it. Okay, sorry. Man, is there a reason? Maybe you guys can explain this to me because I might be jumping ahead here. Is there a reason why OpenGL does everything 0 to 1? Is it just because you can just scale that to any number? Is that why? Okay, gotcha. Thank you. All right, well, there's our screen. Chapter 1 finished. Also, wait a second. That lagged. We're checking memory. We are leaking memory. Wait. How am I leaking memory? It's tiny, but it's there. Am I not? I'm leaking memory somewhere. SDL abstracts over a lot of stuff. Yeah. So I am leaking memory. It's super small. Yeah, because you're not deleting everything. The joys of C++. Well, yeah, I mean, might as well learn it, right? So let's think about this. What am I not deleting? There's only 2 windows. Well, and only 2 buffer instances, right? It's not like we're creating infinite buffers. Every loop, we're leaking something. So what are we leaking in here? It's not this, so it's literally this. There's nothing else I'm leaking, right? That doesn't have to do anything. That's just clearing the color. And then we just clear with this color. And then we just swap the window. I don't understand where the leak is. Oops. If it's very dull, boring black image, yeah, we did it right. If you didn't get the right image, confuse how everything fits together, check out the full source code. This path is relative to that. If you have any issues compiling, yada yada, make sure your code is correct. Input. Okay. You'll get it. In later reading? It's kind of weird to me we're letting a memory leak go. That feels incorrect, but okay. Input. We also want to have some sort of input control. We could achieve this with several input functions. Am I literally just getting Video Game Engine 101? I already know I input. Process input, swap buffers, pull events. Yep. Get key, window, get key, escape, press. Window should close. All right, just press the escape key and escape. Yeah, we already know input. Rendering. I mean, you'll figure it out. Okay, okay. Well, let's think about this. If I clear this, we still have leaks, right? We are leaking memory. So that's not that. Is it this? Yes. Well, no, we are still leaking memory. Oh, okay. So it's this. I'm assuming it has to be. Oh my God. Whoa, okay, something's wrong here. Okay, so clearly not doing that is a problem. Oh, I know what's happening. It's because what we're doing is we're clearing, well, sorry, just to be sure, I think what's happening is that every time we paint over the screen, we're creating more, and we're memory leaking because we're not actually removing the color below it, right? I thought by clear color, it was clear the whole screen and fill in with this color.
gotcha. Okay. Well, if that's the case, this is different from SDL because you had to explicitly say clear with a color, and that kind of did all that work for you. So there's something here that's like we have to do. So GL, what is that, like clear? Bit field. Well, we already cleared with this bit field, so that's not it. GL, color, delete lists, textures, depth range. No. Is there anything like render related? Render mode, render buffer, stencils. GL renderer. Huh. Interesting. Well, I guess it's time to Google, right? OpenGL Reddit. Leaking memory. Just do that. Bind buffer, whatever. Is nobody gonna mention how 2.4 gigabytes for a few dozen models? Yeah, that's a lot. GL gen textures 1. This creates a new texture object every frame. Delete textures. No. So am I supposed to be doing this outside of the main loop? Is that kind of the gimmick here? But don't I have to do that every loop? Otherwise you're gonna have flickering, right? Nope. Yep. Okay, I see what you're saying. No, don't move them out. Yes, you're gonna have flickering. Gotcha, gotcha. Well, to prove that, let's quickly do that. There's our flickering. Well, glad I knew that was coming. Holy cow. Seizure warning. Okay. Glad I at least knew that was gonna work that way. Okay. I know what I want to do. I just don't know how to, like, tell... I don't know how to tell OpenGL that. Because in SDL, it's like SDL renderer clear. Wait, what? SDL clear composition clear. Render clear, that's what it was. And then you cleared the renderer and you're good. That's how you did it. That's how you like wiped the whole screen so you didn't have any leaks. Remember the state machine? Yeah. Well, the only time we ever messed with the state was the viewport. But I don't need to call that every frame. There's no need because that just deals with resolution. So it would be, it wouldn't be like a callback thing, right? I understand what you're saying. I get it. I just don't understand the function call. That's why I'm okay with Googling this, because I understand what I want in my head. I just don't know the term that OpenGL wants. I don't know what specific function call it needs. You are swapping the buffers. The order matters. So we clear the screen with a color. I'm assuming this clears the screen and then only leaves the color left. We then clear with this buffer bit flag, and then we swap the window. And we swap the window because the next frame we do all this, clear the screen, add the color, swap. Clear with color, bit, swap. Color, bit, swap. And in that, we're building up these layers and layers like we're painting a wall without ever like scraping off the old paint. We're just painting forever and making our room a little bit smaller every time. That's what's going on here. I just don't know what function it wants to actually clear everything. Oh. Oh, wait, does it answer it right in front of me because I'm a moron? Just to test if things actually work, we want to clear the screen with the color of our choice at the start of the frame and the clear of the screen. We can clear the screen's color buffer using GL clear, where we pass the buffer bits to specify which buffer we would like to clear. The possible bits we can set are GL color buffer bit, GL depth buffer bit. Right now, we only care about the color values, so this is what we called. We did that. Oh, I just skipped. Okay, my bad. I just skipped the tutorial. I should just do the thing. The poll events, try putting that beneath it. That wouldn't matter for this. Maybe for best practice we would, but that is unrelated to what we're doing here. Note that we also specify the color to clear the screen with clear color. We've already done this here, just incidentally. We call clear and clear the color buffer. The entire color buffer will be filled with the color as configured by GL clear color. This will result in dark greenish bluish color. As you may recall from the OpenGL capture, the GL clear color function is a state setting function, and GL clear is a state using function in that it uses the current state to retrieve the clearing color from. Okay, super similar to what we had here. Gotcha. Okay, we're on the right track. Let's just keep reading. Trust in the process. So right now everything's ready to fill the render loop with lots of rendering calls. But that's for the next chapter. I think we've been rambling for long enough here. Hello, triangle. I want to skip to the part where we call clear everything. I know we're going to come back here in a second. Chat, this is going to bother me. I care a lot about memory leaks. Static draw, buffer data, bind buffer, gen buffers. Maybe not. All right, give it to me. What function am I calling? We'll draw our triangles. That's the next step, but nope. Go through this properly. I thought I did go through it properly. I mean, I can just call the polling event at the end. I feel like it's a little weird though. I'm calling it after rendering? Are you sure? For the triangles, I mean, oh. Hold on, now I'm confused. Okay, hold on. Am I supposed to be leaking memory right now? I guess it's fine. I'm okay with it. If I am expected to be leaking memory right now, we can go on without it. It's a small amount of memory we're leaking. What I'm worried about is as we draw a shit ton of triangles on the screen, and we will be drawing triangles, I'm just worried about like actual memory loss. Like that's what I'm worried about. But if it's something like GL, wait, is it GL clear with another flag or something? Okay. Well, hello triangle. In OpenGL, everything is in 3D space, but no, it's actually bothering me. I can't give it up. I'm sorry. OpenGL learn memory leak first chapter. Memory leak in simple program. Okay. Since rend is a subclass, you must declare a virtual destructor. Nope, not it here. I'm not sure how the SDL wrappers affect memory. Yeah, it can. Memory leak. Yeah, it's fine. It's only like, what, 4 bytes a frame, but you know, it's not insignificant. Actually, no, it's more than that. It's kilobytes. We are leaking right now. OpenGL. We're leaking 8 kilobytes a second. That's a lot of memory leakage. That's a lot of like leakage. I mean, to be fair, we're running 2000 frames a second, so that's how many layers of paint we're adding on. It's just it's just really weird to me. I'm just not used to that with a program so simple. I don't exactly know what I'm doing wrong, to be totally honest with you. OpenGL system memory leak. First chapter. Just tell the end user to get more RAM, problem solved. Yeah, it's difficult. I don't know. It's just annoying. I mean, we'll just go on without it. It's fine for now. It's just, I really hate that memory leak being there, and I don't know what I'm doing wrong. It's 8,000 kilobyte, or it's 8 kilobytes per second. It's just annoying. All right, next. Let's draw a triangle. In OpenGL, everything is in 3D space. Also, hello. Nice to see you. I haven't seen you here before. In OpenGL, everything is in 3D space, but the screen or window is a 2D array of pixels, so a large part of how OpenGL's work is about transforming all 3D coordinates to 2D pixels that fit on your screen. The process of transforming 3D coordinates to 2D pixels is managed by the graphics pipeline of OpenGL. The graphics pipeline can be divided into two large parts. The first transforms your 3D coordinates into 2D coordinates, and the second part transforms the 2D coordinates into actual colored pixels. In this chapter, we'll briefly discuss the graphics pipeline and how we can use it to our advantage to create fancy pixels. Okay, so that's what I just read, I think. Here's what I just read. What it's saying is that within a window of a program, in this OpenGL window, they're saying that within the actual logic of OpenGL, there exists a 3D cube. This is an actual 3D cube in terms of like how it's interpreted by everything in the OpenGL library, you know? Now, to display this cube to us as users, this is not an actual literal 3D space cube. Obviously that's impossible. It needs to display on a 2D like array, right? With an X and a Y value. So in order to do that, there's something called a graphics pipeline, which tells it, okay, this point and this point are clearly more closer together than this point and this point, even though it's a cube and they are technically the same distance. When you render this 3D space cube onto this window in 2D space, you're gonna make these two appear closer together based on a bunch of factors, right? Where the camera is, all that good stuff. So what we're gonna learn right now is that process. Now, they did say there was another step to it. The second part transforms the 2D coordinates into actual colored pixels. Oh, I see what it's saying. So once you have those corners, then paint the pixels wherever they need to be in order to draw those points onto the screen. Okay, so I just skipped a step. Okay, I think I understand that. 8 kilobyte per second leak. Yeah, that is true. All right, cool. Gotcha. Whoops. Okay, thank God. The graphics pipeline takes as input a set of 3D coordinates and transforms these to colored 2D pixels onto the screen. The graphics pipeline can be divided into several steps, where each step requires the output of the previous step as input. Oh, okay, before we draw that, all of these steps are highly specialized. They have one specific function and can easily be executed in parallel. Now that, before I even read on to what it's gonna say, that tells me there's a big focus on, what's the word I'm thinking of? Not coordination, it starts with a C though. It's concurrency. There's a big focus on multi-core stuff. So I'm gonna be glad if we get into like multi-core stuff this early because it's so important, but that's why you do ECS. Because of their parallel nature, the graphics cards of today have thousands of small processing cores to quickly process your data within the graphics pipeline. Never mind. I was thinking CPU, but I guess this is a GPU-based library, isn't it? It's OpenGL. Okay. The processing cores run small programs on the GPU for each step of the pipeline. These small programs are called shaders. Okay, now I will say, I have no experience with shaders. All of my video game programming and video game engine stuff has been through SDL, where we do everything by scratch. I don't have shaders, I don't have all that Gucci stuff, right? We gotta do it all by scratch. So having dedicated shaders is gonna be new to me. So these small programs together are called shaders within the graphics pipeline. I think that's what that's saying. So what it's saying here, this is how I study, by the way, if you guys don't know. I'm taking a class on this. This is how I study. I do very well in school. I usually read a paragraph and then I'm like, okay, did I understand that? So as I understand it, there's something called the graphics pipeline. In the graphics pipeline, you're gonna have a dedicated order of how things happen. Well, many steps, but we'll imagine this is like how it goes. And some of these steps are gonna be shaders. Now, not all of them will be, but some of them will be shaders, right? Gotcha. So it's not the entire thing are all individually shaders. You can have other functions, but some of them are shaders within the graphics pipeline. Gotcha. Vertex and fragment. Okay. The way it phrased it, it kind of made it sound like they're all called shaders under the graphics pipeline. Pixel 2, but I don't see it much. Oh. Some of these shaders are configurable by the developer, which allows us to write our own shaders to replace the existing default shaders. This gives us much more fine-grained control over specific parts of the pipeline, and because they run on the GPU, they can also save us valuable CPU time. Shaders are written in the OpenGL shading language, GLSL, and we'll delve more into that in the next chapter. Before, you'll find an abstract representation of all the stages in the graphics pipeline. Below, Jesus, I can't read. Below, you'll find the representation. Note that the blue sections represent the sections where we can inject our own shaders. So let's see here. So we have our vertex data array, vertex shader. So this is where we can inject our own shaders. Okay. Shape assembly, geometry shader, tests and blending, fragment shader. Oh, fuck, I'm reading it backwards. Oh my God, what a horrible graph. Geometry shader, which we can inject our own shaders into. Rasterization, which we've talked about 2 days ago. I know the difference between rasterization and ray tracing. Fragment shader, which we can again inject our own shader. And then tests and blending. Okay. GLSL is your friend. Geo shaders are slow, but it's not recommended. Okay. So I guess my question is, what is the difference between a geometry shader and a ray tracer? Just super simply. I thought a geometry shader would just be, because in 3D space, the only thing, like the importance of shader. Okay, let me understand this, okay? If an object existed in 3D space, it needs to be lit somehow. If it's not lit, the whole screen is just, it's just empty information. Does that make sense? So when I hear geometry shader, I hear ray tracer. White. Okay, that's a color. Do you want me to respond with indigo? Nope. Okay. Interesting. So I guess we'll read on, but that's my interpretation. As you can see, I don't know what else it would be. As you can see, the graphics pipeline contains a large number of sections that each handle one specific part of converting your vertex data into a fully rendered pixel. We will briefly explain each part of the pipeline in a simplified way to give you a good overview of how the pipeline operates. Wait, geoshaders are like building geometry from the shader. I don't know what that means yet. Ray tracing is a rendering technique. It's nothing specific to shaders. Oh, I don't know. As input to the graphics pipeline, we pass in a list of 3D coordinates that should form a triangle in an array here called vertex data. This vertex data is a collection of vertices. A vertex is a collection of data per 3D coordinate. This vertex's data is representing using vertex attributes that can contain any data we like, probably stuff like textures,
But for simplicity's sake, let's assume that each of these vertex consists of just a 3D position and some color value. Okay, before we even continue, this is how I think it's gonna go. So it's gonna be like struct vertex int x, int y, int z. Struct, wait, what did it want? 3D position and some color value. So then you would have struct triangle that would contain a vertex A, vertex B, vertex C, and then probably some color value of, I don't know what we want to call it, but some like collection of color values. So maybe you would do like struct GL color triangle, and then that was called GL. I just don't know if GL color is already taken as the thing. There, we call it GL color. So then it would be like float R, float B, float G, float alpha. And then this would contain a GL color. That's how I think this is gonna work out here. And then we call whatever functions we need to. A geometry shader basically subdivides triangles. Oh. Well, we'll learn that in a second. Yeah, it's cool for tessellation. Honestly, all I think of when I hear tessellation is just Star Trek Next Generation. What a great show. I love Next Generation. I'm not even that much of a nerd and I like Next Generation. A lot of the level of detail systems do this. A geometry shader is not ideal to use, but it allows a lot of flexibility. Oh, interesting. All right, cool. Well, anyway, that's how I would structure that. All right, what did we learn? In order for OpenGL to know what to make of your collection of coordinates and color values, OpenGL requires you to hint what kind of render types you want to form with the data. Do we want the data rendered as a collection of points, a collection of triangles, or perhaps just one long line? Those hints are called primitives and are given to OpenGL while calling any of the drawing commands. Some of these hints are GL points, GL triangles, GL line strip. Okay. So I think what it's saying here is if I wanted to draw a hexagon on the screen, I would give it a list of GL triangles as a primitive. And I would give it like 6 triangles with the coordinates of a hexagon. I think that's what that's saying here. Yes, okay, cool. The first part, I guess, let me draw it out for people who don't know this, what I was trying to say. What I'm saying is that, like, hey, if I wanted to draw... That's a horrible hexagon. If I wanted to draw this shape, what I'm thinking is like, okay, well, I'll just give it a list of, you know, 6 triangles, and then give it the vertexes of all the necessary information, and then it will draw a hexagon on the screen. That's how I'm imagining what they're saying in my head. Tessellation? Ooh, pretty. Wow, that's like actually hypnotizing. That's weird. Oof. You can do a hexagon with 4 triangles, but yeah. Look at Mr. fucking roller coaster tycoon guy over here. Okay, efficiency guy. Jeez. The first part of the pipeline is a vertex shader that takes as input a single vertex. Primitives help with that, not the verts order. Oh, okay. The first part of the pipeline is the vertex shader that takes as input a single vertex. The main purpose of the vertex shader is to transform 3D coordinates into different 3D coordinates, more on that later, and the vertex shader allows us to do some basic processing on the vertex attributes. Okay, so this is telling me, listen, this is the first step. but don't think too much into it right now. Okay, vertex shader input. Gotcha. The primitive assembly stage takes as input all of the vertices, or vertex if GL points is chosen, from the vertex shader that form a primitive and assembles all the points in the primitive shape given, in this case, a triangle. So this is how I think this order of operations is going right now. Step 1, vertex shader. That is the first step. Now, we're not looking too much into that right now, but that's the first step. Second step is the primitive assembly. So with primitive assembly, what it's doing is it's taking whatever information is here and then translating that into whatever you need it to be. It's super, super basic, like in order stuff. What was that? Spyrodon, Florida, FL. I don't know what that means. Rating with 22. Thank you. Oh, that's so nice of you. Hold on. Come here, you little bitches. Listen, I'm Gary. I'm Gary. Gary the Goo Boy. I stream every single day. And I'm in college for computer science, and we're taking a computer graphics course where I have to learn OpenGL with JavaScript. Fuck. But I know C++. I make video games with C++. As an example, let me actually pull up my card game. Current card game being developed is a remake of an old Flash game called Elements the Game. And this is... boom! Oh, look at that action! Oh, username and Steam profiles and health points and element quanta and art. Ooh, art! This is our current card game we're working on. Whoops. This is our current card game we're working on, and it's a work in progress. We're still getting there, all right? Lots of stuff to work on. I see the enemy username needs to be moved more to the right, but we'll ignore that for a second. Ah, such beautiful art. Astrodeity is the artist that did the art for this game. What a fantastic commission. You redeemed B. Okay, you get a little bit of B. I forgot to turn on the automated boop. Buzz, motherfuckers. Anyway, this is our game right now. I'm in college right now to learn computer programming at a higher level for computer science. And right now we are, for the first time ever, learning OpenGL. All of my games are made through SDL. Oh my God, this is a totally different world, okay? We gotta worry about shaders and shit? Ugh, wild. Anyway, hi everyone. Thank you for stopping by. Thank you for the raid, Mr. Florida man, Spyrodon. Hold on. You can't just raid me and not expect me to pull up your channel on Twitch. We will look at you together. Is this you?
Kid, I really like video games.
Oh, you got a good voice. Hold on. Co-working with Zig, Wasm, and Hitmel, and Laravel, and Actions, and web components. Oh my God. The fucking Hydra of programming languages over here. Ooh. Oh my God. JavaScript. Holy shit. I'm gonna have to learn that soon. Sorry, all of my experience is in C++. It's just like, I see JavaScript and it's like, oh, this would look so much better in C++. That's all I see. I'm so sorry. I like your hoodie. It's so cute. Look at that. Chat, that is a goddamn Eddie Bauer jacket if I've ever... Actually, that's not Eddie Bauer, is it? That's like an anime jacket or something. It does, you're right. Oh. Cool streamer, very cool streamer. Wait, was he like, raid this loser? Oh my God, I want him to... I've had that happen before where somebody raids me and they're like, look at this fucking idiot.
Someone's doing first time OpenGL. Should we send him over there?
Do it.
Send you guys over there. First time OpenGL.
Thank you. I appreciate that. All right, everyone. If you don't know, we're gonna. You
I was
can't
a
just stop, copy, paste. There you go. Follow that man. Thank you for rating. I appreciate it. I hope you like VTubers. I don't know how you feel about VTubers. Listen, I just want to be clear here on the record, okay? Brass tacks.
I don't really like anime. I just want that on the record because people always get the wrong idea, okay? Please, I don't like anime. I'm sorry. I tried. I like the VTuber stuff, not the anime stuff. Says the anime guy. I'm not anime, okay? I am anime adjacent, okay? Saying that's like calling a computer scientist a fucking, I don't know, engineer? I know software engineers exist, but that's different. It's like the wrong name. Imagine opening a comic book and the comic book character's like, I hate comic book characters. What, you never read The Punisher? Or The Boys? I feel like both of those things by that same author is always a very anti-comic book kind of vibe. Don't listen to me, he's a closeted weeb. What the fuck, Sleepy Mushroom? Don't sell me the fuck out. Software engineers are fake, trust me. Hey man, you pay me to be a software engineer, I'll call you whatever you want, all right? Right now, I'm a drug dealer behind bars. Like actually, I'm not making that up. I'm a pharmacy tech that works in a medium security prison, trying to move up in the world with a degree. Thank you for following. Oh, so nice of you. You rated and you followed, you little bitch. Thank you. The output of the primitive assembly stage is passed to the geometry shader. So if there's anything I've learned before we even read about this is that you all hate geometry shading. I don't know why. I'm always hesitant about, oh my God, the gift subs. Why? Hold on, hold on. You can't just come in here with your double-digit dick, all right, with your viewers and just raid me and then gift me subs and follow me, okay? Thank you for all of the gift subs and all the good stuff. That is so nice of you. Eclipse of Hearts, DB9 Dreamer, Big Cheesy Bobby, Wolfie X, Bill's Software. I love that name. You got gift subs. Oh my goodness. I can and did, and you're gonna make it raw. Thank you. Well, these gift subs certainly help pay for everything. Hot damn. That's like lunch the next 2 days. That's 2 trips to Subway, baby. Aw, yeah. That gift sub sound is so loud in my ears and so quiet in yours. Let's turn on some Zelda lo-fi. That's a vibe, right? Wait, what do programmers usually play? I don't watch programming streams. I know what VTubers play. We love our lo-fi. What do programmers play as audio? Like, do programmers play music? I'm not gonna play electro music, okay? I'm not gonna play, like, Darude Sandstorm or whatever programmers listen to, all right? Oh my God, it's still going. Wait, how many gift subs did you give? It was 5, right? Damn. Oh my goodness, I just minimized everything. Ugh. Well, thank you so much, Spyrodon. Okay, so programmers play music, but you want to know the real secret? Do I want to know the real secret? Or are you gonna give me some hazing bullshit like I'm gonna get this fucking moron? I'm considering playing metal one of these days. I like metal if it's wow, we're so off topic right now. We'll get back to geometry shaders in a second. I like metal if it's like actually, I like screamo metal sometimes. I don't mind it. It just has to be like, it has to be melodic without going like so melodic I can't even understand what's going on. I care a lot about melody. If the metal song has a good melody, I really like listening to it. That's why I like Metallica. Factoria music. Factoria, is that like Transfactorio? The micromanagement sounds of grinding gears get them hard. Ew. All right, geometry shader. Now, if there's anything I know about a geometry shader is that you guys hate it. But what I'm learning about the tech industry is that you guys are so strongly opinionated about something when it's like the not smallest deal it can ever be. Mountains out of molehills, people, okay? I'm learning to not trust you people when you say you don't like something, okay? I was wondering, hey guys, what programming language should I learn? And everybody's like, not C++. It's a nightmare to learn. It's the worst. And you know what, chat? Out of all the programming languages I learned, I kind of surface level glanced over, guess what? C++ was the easiest to understand for me. I don't know, Python is hard for me. Like Python is like super difficult, like interpreted language versus like compiled language. I like having the compiled language and it made me learn better because I learned errors before like They fucking happened. Wait, what? You legit like C++ unfollow? No, I actually do. It's my favorite language. Mainly because I know the most about it. Dude, how can you hate C++ when we have by the way, this is how we're learning OpenGL right now. How can you hate C++ when look at this? Import SDL, OpenGL header, import standard library. And guess what, motherfucker? We don't do no hashtag include shit, okay? Actually, I don't have to do this, but I'm too lazy to fix it right now. We don't need to do this shit, okay? Gone are the days where you're like, hashtag include chrono, hashtag include permission to do math, hashtag include permission to, fuck that, okay? Studio, we're not doing that, okay? It's import the standard library, and every time you use a function that's in the standard library, like standard print line, which is printable, thank you Visual Studio, print line, whatever you do, right? Boom, 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 comma, get, error, yada, yada, right? Whatever this is, right? This is like C++ 23 shit, right? Gone are the days of cout. Whenever I call that, it's like, okay, well, pull up the standard library and it just does it. It is so nice. Oh, it's so fast. I love C++. 5 subs back. Listen, you're a dirty JavaScripter. Imagine programming in JavaScript and criticizing C++. It's like, oh, hey, do you like apples? No. Do you like apple pie? Yeah. It's like, what the fuck? The thing you'll find most useful ever is if you take something someone says sucks and try it for yourself and come up with your take. Well, that's what we're gonna read about. I'm reading so slow right now after the raid. That's what we're doing about a geometry shader. Is everyone's saying it sucks, but I don't know why it sucks, and I don't wanna like assume it sucks before I even get into it. I'm gonna go into it with an open mind. Okay, look, real talk, everyone's brain is different, so some people didn't you stop streaming like 15 minutes ago? Your poor viewers, they all come in here with you on a raid after they love watching their favorite streamer stream for the night, and you end the stream and you raid me and now you're in my chat. How does that make your viewers feel, huh? Don't they feel a little bit outcasted? Like, what the fuck? You know what? Vibes, because I can't tell you, as a VTuber, I know a lot of artists who are VTubers. They all complain about the same thing, and it's exactly what I just made fun of you for now. They always complain that's like, listen, I know I'm doing your commission right now, but like, I want to stream and kind of do my own thing. And it's like, they all complain about like, they're worried like the person that commissioned them is going to complain in chat about like, why aren't you working on my commission? It's so like funny to me. Like every artist I commission asks for the same thing. It's like, hey man, is it okay if I stream and like not do your commission? Every artist I've ever commissioned has asked me permission to do that. I'm like, fuck it, Jesus. I paid you, we have a due date. Do whatever you want until then, I don't care. Okay, sorry, I totally didn't read your message. And some people don't, so I totally understand. Also, C++ objectively sucks. Source, trust me, bro. Nah, I like C++. I like the control it gives you a lot. That's why that card game that we just showed like 10 minutes ago, I can play that shit on actually, somebody, I'm vouching for like one of my viewers. He played it on integrated graphics on one of his laptops, and you know what? It fucking worked. So I'm proud of what we're doing, okay? I think I'm at like 55 megabytes of RAM on it. I'm waiting until you find Vulkan, and that's when you find out C is better. Guess what? I am only learning OpenGL because this is one of the required readings for my degree. My computer graphics class requires like 4 fucking readings, and this is one of them. So, you know, might as well learn it now. Play Warzone and play Urzikstan. I don't like first-person shooters. I don't like the violence. I like nicer games. Listen, if I have to, I'll come onto your stream and we can hash this out and both our viewers can enjoy this and I won't VTube. I'll actually be a real person and use JavaScript. Do I turn on my camera right now? Am I dressed? I'm dressed. Hold on, I'm gonna turn on my camera. I feel like you guys are judging me. God damn it. 1 second, let me clean up a little. You know what? Fuck it, you guys can see me in my rawest form. Hold on. camera. Hi. Where's my zoom in? Hold on. Turn off that. I just got a haircut. You can't judge me. Hold on. Where's my El Gato? There it is. And then we drag it. Hi. How's it going? How's it going, chat? Listen, all right? I just got a haircut. You can't judge me. I have loose hair everywhere. It's too short, right? Right? It's too short. I don't... Do we like this? Do we like this? I don't know. Gary is super cute. You're super cute. I like VTubing more though. Nah, hair be looking fine. I am a tick tick boom. Hello. Deepfake AI. No, it's real. I just don't really like streaming IRL because I'm constantly like looking at myself and I'm like, oh, I need to lose weight here. I need to shave. It's like I'm constantly like I'm just constantly looking at myself and it's really distracting. Whereas if I'm just like Gary on the screen, like whoop, or if it's like this, it's like, oh my goodness, we can stream and do stuff. Whereas here it's just like, you know, following. Tick Tick Boom is following again. Your name sounds really familiar. You've been here a lot. Thank you for finally following, I guess. Nah, haircut be looking fine. Fresh cut. That's why you, oh, if you guys are wondering why my VTube model constantly shakes his head, it's because I'm rotating in my chair like this. That's why you grow your hair long and long beard like me, and then you don't have to worry about it. No, I want to be a programmer that's like I'm a people person. I just happen to also really like computers and technology, hence the VTubing stuff. All the new followers, once I turned on my camera. What are you guys implying with that? Are you saying that you're only gonna follow me because you found out I'm not hideous? Is that what you're doing? Chat. Yes, I have a GF IRL. I have an IRL GF. Thank you for following though, I appreciate it. What Sorry, I have a bag of trash I'm gonna throw out there. I wasn't expecting the IRL VTube, so I haven't had a chance to clean up. That's why there's that's a flycatcher. That's my piano, by the way, right there. That's Tifa's theme from Final Fantasy VII. Simps? I think you have simps? No, I don't. Chat, don't simp for me. There's so many more attractive people who are not over. I'm not even that overweight. I'm a little overweight right now. That's why I should look at this, chat. I should be that skinny. Oh, I'm so attractive. Mom, get the camera. Look at that chin. I'm a fat fuck right now. All right, we're gonna turn off the camera because again, all I'm doing is looking at myself. All right, get that camera out of my face. What were we doing? Oh, we were learning the stages of it. Anyway, thank you for all the follows today. I appreciate it. What was I saying? Oh, I wouldn't know. My room is plastered with pictures of myself. Oh. But yeah, if we ever stream together, which, hey, you know what? I'm cool with it. Remember, actually, Spyronodon, your name sounds like a dinosaur. Spyronodon, listen, all right? Real talk, my first class that starts in like 10 days. By college student, by the way, I mean, I literally start in 10 days with my first college class. My first class, I have to learn Python. And Discord is below the stream. I have to learn Python. And then after that, I learn Java. And then Java. And then along the way, I'm learning JavaScript and SQL and R? The statistics programming language? I didn't even know you had to learn programming and statistics, but there you go. Maybe when I start learning JavaScript, I kind of employ you to kind of, you know, tell me how much better JavaScript is in C++. You can be like, oh, but look at this cool thing you can do. Oh. I'll be like, oh, it's okay. The geometry shader takes as input a collection of vertices that form a primitive and has the ability to generate other shapes by emitting new vertices to form new or other primitives. In this example case, it generates a second triangle out of a given shape. So what's going on? It takes as input a collection of vertices that form a primitive. You know what? Fuck the paint thing. I need to do this in programming land. Okay. So vertex shader. Vertex. Okay, so let's do, obviously this is like pseudo programming, so bear with me here. So we have vertex shader. This will take as input, just to confirm, a single vertex. Okay, boom, that's step one. Then step two, primitive assembly will take as input a vertex array that will contain some list of vertexes that have all of the information we need, right? Am I understanding this so far? Okay, now, then what we're gonna do is have a geometry shader okay. Oh my God, Visual Studio, Jesus. Geometry shader. And this geometry shader will take the same array of vertexes, or is it something else? Geometry shaders just create geometry from the shader. Yeah, DirectX 11 and below is more like OpenGL. DirectX 12 is very similar to Vulkan in verbosity, structure, and low levelness. Well, I'm not interested in... Listen, okay, just a reminder, I program in C++. Verbosity gets me hard, but we're in like 3D land. All of my experience is in 2D, SDL, like no shaders land. Like that's where all my programming experience is. So as we step into like the very complicated world of 3D rendering, I need to be super careful about what I learn. Right now, I'm more interested in like the process of rendering than I am about like how we render it necessarily, you know? That's why we're learning OpenGL. Plus it's required for class. Are you a sentient fluid simulation? How many liters are you? How many liters is 185 pounds. And I'm 5'9" on a good day. Dude, you need to look at Vulkan at some point if you like that. Well, we'll get there. Talk to me with big words, baby. Oh, don't worry. Was only talking about the previous comment. You were doing the correct path. Okay, thank you. So are we learning basics or trying to understand the full spectrum? Oh, we are doing what's required for class, reading this book of many, and along the way, once we learn OpenGL, we can expand our horizons. All I really want to do in terms of video game stuff on my own right now is if we do anything with OpenGL is just make a 2D game in an OpenGL context. That's really all my goal would be. If I can do that, we'll pretty much only stick to OpenGL from now on. But I feel like that's a natural next step rather than going like, oh, I know OpenGL, time to make an MMO. I don't know how well my face can capture that emote. It's like, I want to make an MMO. It kind of does. I'm kind of doing the sideways mouth like, You sure it's kind of hard for a 2D game in OpenGL? Yeah, it's kind of hard, but is it kind of hard like C++ hard? Keep in mind, I only started programming in February, okay? So I got a little bit of a pass here. Use the love source code as a reference. It uses OpenGL and SDL2 for 2D games in C++. Thank you, Lofally. I'm also going to use the live source code. No, I think we're getting it so far. I haven't had to look in any code yet. The only thing I'm worried about is we do have a 8 kilobyte per second memory leak, but we'll ignore that for now. I do have a ton of experience in SDL, and it's actually how we're getting the OpenGL context going. So that's why it's SDL GL swap window. So with that in mind, we're already doing SDL too. I would say 3D in OpenGL is easier than 2D in OpenGL. Very different beast. Oh, I didn't know that. All right, anyway, geometry shader, vertex array. Gotcha, go. The output of the geometry shader is then passed on to the rasterization stage, where it maps the resulting primitives to the corresponding pixels on the final screen, resulting in fragments for the fragment shader to use. Before the fragment shader can run, clipping is performed. Clipping discards all fragments that are outside your view, increasing performance. Oh, that's automatic? Oh, that's not how I expected that to work. You know what, chat? I ain't gonna lie. I thought out of view, like not rendering, I thought that shit was gonna be complicated to implement on my own. Cause I know I have no experience with Unreal Engine, but I just know there's just a button you can press to kind of not render things outside of your point of view. I didn't realize that was like already implemented with OpenGL. SDL does exit for this reason. The fact that you can create a quad that easy is a godsend. Oh. SDL does exist for this reason, and the fact that you can create a quad that easy is godsend. Well, we already did our custom quads when we did our bullet hell shooter. We did like a custom quad. We rotated the quad based on trigonometry. We already did all that stuff. I'm not sure if it's much more complicated than that, is it? In like a 2D context. The projection is written all by hand. Oh. There's a scissor function as well for limiting rendering to a rect. Yeah, scissors do be nice. Oh, interesting. A fragment in OpenGL is all the data required for OpenGL to render a single pixel. Also, wait, hold on. Oh, I misunderstood. Oh, hold on. Okay, I need paint. Let me understand this correctly, chat. Maybe you guys can correct me. So, every process is this, okay? Going through every process here, right? So we have our vertex shader. That's our vertex. It has an X, a Y, a Z value, and color and whatever else we need the individual vertex to hold. That individual vertex is going through the vertex shader. Now, correct me if I'm wrong, every single individual vertex on the screen that will ever be displayed in any context all have to go through a vertex shader. Every single one of them. You can't dodge this step. Right, okay. Now, once every vertex goes through a vertex shader, yes. Okay, thank you. Vertex shader, then we go to a step called primitive assembly. By the way, we're assuming everything is dealing with triangles here, not individual points. So just bear with me a second. So with a primitive assembly, we're gonna give it the list of vectors for a given triangle. That's all we're doing right now is just drawing a triangle. So we have 3 vertexes, all go through the vertex shader. These 3 vertexes are gonna be fed into, into the primitive assembly. Now, this does not, to be clear, draw a triangle. All it does is it assembles the 3 vertexes, basically makes them one object. That's really all it does as far as I can tell. So these 3 vertexes, they're not just random X, Y, Z values in space, right? They're all values associated with the same object, but that's all that really does. Yeah, you don't need to do primitive assembly for WebGL. Well, that's good to know because I have to learn WebGL. Now, next we have geometry shader. So the geometry shader is where we get fragments, okay? So these vertexes at this stage turn into fragments. Now, I don't know the importance of that. No lines are drawn between these points yet, but this is that point, okay? I don't know what that means, but they are fragments, okay? The only description it gave me was, is all of the data required for OpenGL to render a single pixel. Did I skip a step? Geometry shader. The geometry shader takes as input a collection of vertices that form a primitive, this, and has the ability to generate other shapes by emitting new vertices to form a new other primitives. Oh, I got you. So geometry shader, what it does is if I have like a hexagon to build or something, or a diamond, for example, if I have a diamond I'm building, what I can do is give it 2 of these objects where that's the diamond, right? So it's 2 objects that are now 1 object under the geometry shader. I think that's what that means. Geometry shaders are like vertex kaleidoscopes. Okay, that makes sense. Geometry is an extra step. You won't need one for 2D. Well, I still have to learn it lawfully. Okay, listen, if I was doing this as a personal project, I would agree with you, skip it, but I'm doing this for like school and potentially a job, so I have to do it. Now, the output of that is the rasterization stage, where it maps the resulting primitives to the corresponding pixels on the final screen, resulting in fragments for the fragment shader to use. Okay, so now we still have 3 fragments on the screen that are themselves vertexes that themselves contain some combination of like an XYZ value, maybe a color. It could be a lot of information, but they are vertexes, now fragments, and now they're on my screen. Still not drawn as a triangle, but they are an object, each containing fragments with some rendering information on there. So rasterization is just putting those fragments onto the screen to do other things with, okay? Gotcha. Fragments like a pixel with a lot more information involved. Yeah. So from there, we have clipping. So clipping is, okay, well, let's say we don't see that fragment, right? Let's say all of the information is in this window. This is like the window we see, right? This is outside of the window. This fragment doesn't get rendered for performance reasons, right? Because there's no reason you would ever want this to be visible to the player unless it's like a very specific reason why. You have to know why you would want that, otherwise default behavior, okay? Cool, so that's when clipping is performed. What is up with my windows right now? The main purpose of the fragment shader is to calculate the final color of the pixel, and this is usually the stage where all of the advanced OpenGL effects occur. Usually, the fragment shader contains the data about the 3D scene that can be used to calculate the final pixel color, like light, shadows, color, and the light of the light, and so on. Okay, so now we're at the fragment shader stage. Now at this point, what's going to happen is we still haven't drawn the triangle yet, but every fragment already has rendering information in there. The fragment stage, that's called that, right? Fragment shader stage, what it does is it takes that information and actually applies it. So if this is like, if we have like a sunset in the background or something, okay, well, these are going to be more affected by red and orange. This is going to be more purple, black, blue, like that kind of deal, right? It applies the information that we fed it in like the screen to be shown to the person, to the user. You're a quick study. Thank you. I've always done really well in school. By the way, if I wasn't doing this on stream, I'd be doing this in my head. This is exactly how I learned, by the way. Except instead of asking you guys, I would just be Googling it. So this is a lot faster. Fragment shader helps with lighting to be displayed on a 2D screen. Not the only case, but okay. After all the corresponding color values have been determined, so every other step is done, we have 3 fragments on the screen. Like all the information is ready to be rendered if it hasn't already. Now, the final object will then pass through one more stage, and we call that the alpha test and blending stage, which is going to be obvious, but okay. This stage checks the corresponding depth and stencil value, we'll get to those later, of the fragment and uses those to check if the resulting fragment is in front or behind other objects and should be discarded accordingly. The stage also checks for alpha values, the opacity, and blends the objects accordingly. So even if a pixel output color is calculated in the fragment shader, the final pixel color could be something entirely different when rendering multiple triangles. Okay, well that's pretty self-explanatory, right? So if we have a cube here, or, well, I don't want to draw a cube, whatever. If we have a cube here in front of the triangle, right? Well, what happens to this vertex? Sorry, this fragment? Well, it's not rendered, much in the same way how if it's outside of the context of the window, the outside window fragments aren't rendered, right? So it's the same logic there. Then it talks about opacity. So if you have like, you know, fog effect object in front of these 2 vertices, yeah, the actual individual fragments may have a color associated with it, may have some sort of, like every vertex had like a color information behind it, or could. The individual color, you don't change. That is the color it is. But if you have other opacity based objects in front of it, well, the color is going to change, but OpenGL takes care of that at this stage automatically. I think automatically. The data a fragment shader inherits from the vertex geometry shaders is a weighted blend of the values of the vertices of the primitive. Okay, that makes sense. Not one fragment per vertex, by the way. Well, we haven't ran into that yet, but makes sense. As you can see, the graphics pipeline is quite a complex whole. It contains many configurable parts. However, for almost all the cases, we only have to work with the vertex and fragment shader. The geometry shader is optional and usually left to its default shader. There is also the tessellation stage and transform feedback loop that we haven't depicted here, but that's something for later. Okay, sweet. So the geometry shader is optional, probably not going to make it optional for the foreseeable future for the sake of like learning, but it's optional. At Gary, click. Triangle rasterization. Did you just link me a 2-hour video? What the fuck is this Lord of the Rings shit? God, remember back in the day on the internet, people just made videos and said what the fuck they were? God, 2 hours. Holy shit. I swear to God, if I hear this guy say anything like follow and subscribe, I'm gonna blow a gasket, okay? 2 hours.
Hello, everyone. Welcome back.
Okay,
So
hello.
today we're going to take a look at some things.
Chat, 0 out of 10, rate his beard. How do we feel about this? I give it like, compliment sandwich. I love the color, okay? It's not graying. You can tell he's getting a little bit later in life. He rocks the hair, but it's not graying, so I love the color, okay? I think the hair is a little bit too long. It looks like he's more overweight than he actually is because this hair is so long. It kind of gives him like a double chin effect, even though it's not, it's just his hair's long. I would give it like a 4 because there's a lot of room for improvement. Personally. Also, it makes his chin look way more like Kronk than he's probably expecting. Like, it's like great jawline, and then bleh, too long. But I like it.
Super important, which sits at the base of the pyramid of a lot of our courses here at the school. If you ever took a course with us, you know that...
All right, this shouldn't be 2 hours long. Next. But thank you, I appreciate it. Listen, back in my day, you had your video and you just, oh man, instead of YouTube videos, you know what you can do if you really want to link me something like that? A goddamn Reddit post. Holy shit, I will read the fuck out of that. I'm a reader, not a watcher, okay? I connect, like knowledge-wise, I associate like reading with learning. I like to read more than I like to watch YouTube videos. I just don't have the patience. I say, as you guys are watching a stream, man, I'm a 20 viewer Andy today, huh? Well, hi, everyone. In modern OpenGL, we are required with bold to define at least a vertex and fragment shader of our own. There are no default vertex fragment shaders on the GPU. For this reason, it is often quite difficult to learning modern OpenGL since a great deal of knowledge is required before being able to render your first triangle. Once you do get to finally render your triangle at the end of this chapter, you will end up knowing a lot more about graphics programming. Okay. So once you have your first triangle, okay, so this is like a learning cliff kind of situation, right? Where we're gonna learn a bunch of stuff at once in bulk, but once we get over that first hill, it's all just minutia stuff, right? It gets more complicated, obviously, but I would imagine once we get over that big hill of like the rendering pipeline, we can go through step by step and just learn every individual stage much more in depth. That's what I'm imagining this is gonna go. It's the same thing with C++, right? Like you need to know the difference between like references and copies when it comes to like parameters of an argument. And pointers and stuff like that. But once you have all that stuff down, like it's not that hard, right? Vertex input, ooh. To start drawing something, we have to first give OpenGL some input vertex data. OpenGL is a 3D graphics library. Library? Are we sure we're gonna define OpenGL as a library? I think that's an incorrect statement. OpenGL is not a library. OpenGL is a set of standards that are then applied by third-party people, usually in the form of a library. Ha! I learned shit. OpenGL is a 3D graphics set of instructions, so all coordinates that we specify in OpenGL are in 3D. X, Y, and Z coordinates.
OpenGL does not have, yes, API. Oh, thank you. OpenGL does not simply transform all your 3D coordinates into 2D pixels on your screen, semicolon. OpenGL only processes 3D coordinates when they're in a specific range between -1 and 1 on all three axes, X, Y, and Z. All coordinates within this so-called normalized device coordinates range will end up visible on your screen, and all coordinates outside of this region will. Okay, so when we were earlier talking about -1 to 1, right? That whole window, like hold on, let me actually compile again here. So when we were talking about like this screen, right? Nice color. The 1, -1, 1, -1. This screen is called normalized device coordinates. Okay, normalized device coordinates. That seems like a very important term to remember. All right. You have a better understanding of that than some folks who have been using it for years? I don't want to say that, only because I'm literally reading it out of the textbook. If you put this textbook in front of any of those people, I promise you they will know more about this than I do, okay? I'm just reading the textbook and applying the knowledge. That's all I'm doing here, okay? There's no better understanding, there's no depth, there's no high IQ thing here going on. I'm just reading and repeating. That's the stage that we're learning at right now. I haven't even drawn a triangle yet. Okay, so let's calm our horses here a little. I get people who claim to have read all about Vulkan and insist it's a library. But later, oh, you're talking about the library thing. Oh yeah, no, that's not a library. Only because last time we learned this, it was made very clear to me. We had like a zero stream where we were like linking everything to, and with SDL and Visual Studio and everything. So we had an OpenGL stream, but it was just setting up everything, and I learned that there. When you get angry, do you boil? When I get angry, I get, how do I say this? When I get angry, I withdraw and I judge. I get resentful. That's just the way I am. I can't really, I've tried, it's a bad habit, but I do withdraw and then I get resentful about the person, and I hold it for like such a long time, right? And I'm very like bottle it up kind of person. So it's just like, okay. And then like, I won't say that, but like, okay, sure. But I'll judge you silently and I'll resent you, but I'll be professional. Like that's basically how I get angry. On stream, I don't really get angry on stream, no. So many folks say it's a library. Yeah, well, you learn something, you learn something. Because we want to render a single triangle, we want to specify a total of 3 vertices with each vertex having a 3D position. We define them in a normalized device coordinates, the visible region of OpenGL, in a float array. Oh, okay. What is this array doing? So we have a float array containing vertices array equals -0.5, -0.5, 0, 0.5, -0.5, 0. Oh, XYZ, XYZ, XYZ. I understand that. Wouldn't it be better? I feel like if I made this tutorial, I would just make everyone give a struct, vertex, and then just have also, is this a raw array? Oh no, wait, hold on. Chat, please don't tell me that OpenGL requires raw dog fucking no condom arrays. Oh no, I can't do standard array? That's disgusting, chat. Can I not do like like I want to do something like struct vertex int, ooh no, it's gonna be float x, float y, float z, and then have somewhere else have a standard well, it would actually be, yeah, it would be an array.
a standard array containing vertex 3 triangle is equal to, well, I guess I can just do this, huh? X, Y, Z. Oh no, it would be shit. Whatever, you guys get what I'm getting at, right? But I can't do this, right? It's because it's a C interface. Just do dat data parentheses on your CPP array. Wait, I can do that? Yeah, I'm not doing no C-based array. What the? I never knew that. Wait, standard triangle dot data. I can just do that? Oh my God, thank you. Oh, my life is saved. Okay. Oh, hallelujah. I was worried I was going to have to do C-based arrays and I just wanted to cry myself to sleep. Chat, do you know what it's like? It's like, imagine you meet somebody and he is the perfect person. He's tall, he's handsome, he's like athletic and he's strong and he's nice and he's smart. And then he has a dumbass older brother, and this dumbass older brother is a drinker, and he's old, and he has gray hair, and he's balding, and he does drugs, and like this younger person is just so nice, and you want to hang out with him, but he always has to bring along his dumbass older brother because everybody just knows the older brother, and it's just like, fuck, all right, fine, I'll hang out with the older brother too, but it's mainly because of the younger brother. That's how I feel with C++ and C. Just please, C, get out of my life. I want C++. Oh my God. Yeah, it's all contiguous memory internally. Data function gets the underlying array. And then vert push back. You could go about this as well. I don't think we're going to need to push back or anything. I think we're just going to make a, well, not a class, probably just make multiple structs Sleepy Mushroom and just do it all by hand by now. We don't need to expand this program. It's just a test program to learn OpenGL. The vert size and the vert data is super useful. Okay. Vert size data. Okay. Using structs, you will likely have to map the structs into a flat list of floats before submitting it to OpenGL. That's okay. What's Rust in this analogy? Rust is the cousin that lost all of its money on Bitcoin and you don't ask any questions about it because it's kind of rude. That's Rust. C is amazing. Don't underestimate it. C is amazing. I'm with Travis on this. C is a true programmer's passion. Yeah, C can suck my gooey balls, okay? C++ is how everyone knows about C, okay? Don't act like you're not riding some coattails here, all right? You got age on us, and that's about it, all right? Rust is like the Catholic path. No. Rust lost money. Dude, it's totally the other way around, LOL. Nah, get off my lawn, kiddos. Next. Because OpenGL works in 3D space, we render a 2D triangle with each vertex having a z coordinate of 0, 0. This way, the depth of the triangle remains the same, making it look like it's 2D. Okay. Before we get to that, what's the next step here? Okay, so we'll worry about the buffers in a bit. Let's do this array thing we were talking about here. Okay, so let's make some structs. Those go before functions. Struct vertex. This is going to contain a float x, a float y, and a float z. Ignore the fact that these floats are way more memory needed than we actually need for the x, y, and z values. Ignore that for a second. Struct, well, ignore that forever. We're gonna do that later. Struct, and then we're gonna have, we don't need colors and all that right now, right? So we'll just do floats. Then we're gonna have a struct. Did we get cute with it? Nah, we'll just do struct triangle. I was about to do struct shape, but that's kind of taking the piss. So struct triangle will contain vertex A, vertex B, vertex C, and that's how we construct the triangle. Okay, sweet. Do you water your lawn by running around in it? What did I miss? I didn't know Rust touched everyone. What? Server infrastructure, photography, modding. I mean, yeah, most games using it today for that. Oh, I see what you're saying, Sleepy Mushroom. It's too safe. Yeah. Rust forces a way of writing code to not cause memory leaks, but it does it in a single way, and it's quite opinionated, which makes it rather chalk and cheese. Oh, no, I actually don't like that, because I am a C++ programmer, okay? My memory leak prevention is my eyes, okay? My garbage collector is my operating system, okay? Get the fuck off my lawn. Rust, users, go lose more money on Bitcoin, okay? Big boys are programming, okay? So we have our 3 float values, and then we have our 3 vertexes making a triangle. That's all of this. So now we're gonna make this value. So -0.5, -0.5, 0. What am I drawing? This. I'm drawing this. Okay. Okay, so let's do that. Before we go the render loop. Hold on, let me do some commenting here. Input, rendering, loop. Okay. Fuck it. So vertex A, well, vertex 1 is equal to, no, fuck, I'm doing this wrong. Auto 1 equals vertex -0.5, -0.5. Last one? Data entry 0.0. Oh, can C do that syntax? Fuck no. I'm an always auto king, baby. How long have you been programming C++? All of my programming experience started in late January. Everything you see here is within 5 months of learning. Like, seriously, it's on stream. My first program was like hello world, and I fucked up the syntax, all right? That's where I started. Noted? Ah, excuse me. Are you judging? Homegrown rendering with Rust? Pfft, fuck that. All right. Then we have auto 2. Fuck it. V1. There, is that better? V2 is equal to vertex. What values now? There you go. What is this F shit? Okay, and then auto v3 equals vertex. Values here. Comma. Okay, so now we need to make an array. Ooh, actually, hold on. Let me think about this. It's probably better if we don't have 3 vertexes here, because this is all going in an array anyway. This should be a standard array vertex 3 shape for now. That's what that should be. That's a better thing. So now we're gonna have a triangle. Fuck. We're calling this shape. Shape triangle auto triangle equals shape A, B, C. there a better way to do this? Can I do that? That's a better way to do it, right? There we go. Okay, that's what I wanted. F means float. Yeah, I know. I just didn't know why they specified float values here. Is it because these are interpreted as doubles? Oh my god, they are doubles. Fuck. Oh my god, the F's do need to be there. Damn it. I hate being proven wrong, chat. Okay, now we have our triangle shape. This array contains vertexes, 3 of them, with these values. So this, which is going to be triangle dot shape array, is the same value as this raw C array. Okay, beautiful. Normalized. All right, well, let's remember that. Normalized device coordinates. Once your vertex coordinates have been processed into the vertex shader, they should be in a normalized device coordinates, which is a small space where the x, y, and z values vary from -1 to 1. Any coordinates that fall outside of this range will be discarded or clipped and won't be visible. Below you can see the triangle we specified within normalized device coordinates, ignoring the z-axis. Yep. Unlike the usual screen coordinates, the positive y-axis points in the up direction and the 0, 0 coordinates are at the center of the graph instead of the top left. Eventually, you want all of the transform coordinates to end up in this coordinate space, otherwise they won't be visible. Your NDC coordinates will then be transferred to the screen space coordinates via the viewport transform using the data you provided with the viewport. The resulting screen space coordinates are then transformed into fragments as inputs of your fragment shader. Okay, all that makes sense. This is just review. With the vertex data we defined, we'd like to send it as input to the first process of the graphics pipeline, the vertex shader. This is done by creating memory on the GPU where we store the vertex data, configure how OpenGL should interpret the memory, and specify how to send the data to the graphics card. The vertex shader then processes as much vertices as we tell it to from its memory. Okay, so this is not done automatically. We do actually have to specify creating memory on the GPU, all that stuff. Okay. Vertex pointer time, baby! Hell yeah. We manage this memory via a so-called vertex buffer objects, VBO, that can store a large number of vertices in the GPU's memory. Probably to the tune of like, I don't know, millions probably. I don't know how much, but I have a water-cooled 4090, so millions. The advantage of using those buffer objects is that we can send large batches of data all at once to the graphics card and keep it there if there's enough memory left, without having to send data one vertex at a time. Billions! Sending data to the graphics card from the CPU is relatively slow, so wherever we can, we try to send as much data as possible at once. Once the data to the graphics card memory, the vertex shader has almost instant access to the vertices, making it extremely fast. A vertex buffer object is our first occurrence of an OpenGL object, as we've discussed in the OpenGL chapter. Just like any object in OpenGL, this buffer has a unique ID corresponding to that buffer, so we can generate one with a buffer ID using genBuffers function. So unsigned int. Wow, that's going to be a very big fucking number. What is that? 4 billion? So we're going to generate a buffers. Okay. So unsigned int VBO. So this is our buffer. And then we're going to call GL generate buffers, which is SDL GL gen. This is so hard to read. Let's see. Float buffers, data buffers, gen buffers, gen buffers, gen buffers. Draw buffers. Should be gen buffers, right?
Gen buffers. What would that be called? SDL, GL, gen buffers. All right, Google. SDL, GL, gen buffers. Does not exist. Okay. GL, gen buffers in SDL. Create window, set attributes. GL gen buffers. Wait, I have that? Oh, wait, I have that? No, I don't. What the fuck? I just find having very strong opinions about programming topics as you do can be quite destructive given your amount of experience. Just my opinion though. Well, there's a difference between good fun and, you know, learning. I know my place in the world. Ah, that's not my 4090. I mean, it's a 4090. It is my 4090 technically, but I have the Supreme. Hold on. Can I just search this up? Supreme. This is what I have. Quad slot? Wait, this isn't what I have. No, that's not what I have at all. Hold on. Supreme 4090. Where's my water cooled? There we go. That's my boy. That's my graphics card. No, it is Supreme. It's SUPRIM. How you doing? Some bad awesome. Thank you. I'm doing well. I'm doing pretty dang good. I didn't know I had a clock on mine. Wait, I do? Fuck you, I have a clock on mine. I don't have a clock on mine. That's fake. That's fake news. Yeah, that's what it looks like in my system though. That's the bottom of it anyway. That's the top. It's a very good 4090. I have no issues with it. Oh, that's what the inside of it looks like? Oh, cool. Yeah, very good 4090 though. Well, I mean, it's a 4090. You can't go wrong with it, but still. There you go. Retails for 150 more, but it's water cooled and apparently has a higher boost clock. And that's the only difference. I just got it mainly because I have a height Y60, which does not play nice with big graphics cards. So I just got a water cooled 4090. Retails for $17.50. Yeah, that's about right. Paid a lot of money for that. So I need to find that function, which I don't have easy access to. So in SDL. Where are people getting this? Include? Did I delete the include? Is that what happened? No, it's there. Why don't I have that function? Is it new? Or did they change it in like a new thing? Maybe this? No, we already had our thing. We already found it. Do you use some OpenGL loader? Well, what I do, Ubuntu, is that we have SDL, and in SDL we have an OpenGL library, and then we include gl.header. That's all there. So we have OpenGL. It does GL render clear, GL clear, but what I don't have is GL generate a buffer. I don't have that. I don't know why. That should be there. So that's where is it like SDL? Gen buffer? No. Confusing.
Let's see, include OpenGL GL3, OpenGL GLEXT. I don't have those. Does that matter? That shouldn't matter though, right? Well, let's Google it. Basic coding, Chronos forums. I run an OpenGL higher than 1.5. I can make use of a function called glgen buffers. When I call the command that, I receive term, yeah. You need to get pointers to functions above version 1.1. I recommend you use the extension loading library. Oh, I need a pointer to it? That shouldn't matter. I already found the call who made the error. Now it works. What? Oh, is it called something else now? Is that what's going on? GL bind buffer binds a buffer object to the specified buffer binding points. No, this code will only work in a compatibility profile context. Huh. You use some OpenGL loader? No, I don't. It's quite normal and expected to have something like define GL dex prototypes, include that. If you're trying to write OpenGL 3 compliant code, you normally change that to 1, 1. Oh, is that how they're getting me? With some redefinition shit? By using the glgen buffers function. It just assumes I have it. You got glad? No, I'm using SDL. Ghost? That took a while to turn on. I wonder what happened there. Oh, I'm a spooky ghost. Very scary. So I guess it's an SDL thing. They must call it something else, right? Buffer size, double buffers, float buffers. That's for SDL video though, right? That's, oh, it is GL. They must call it something else. Buffer storage? Buffer size? Mapped? It must be a different name. Hi, when I try to compile my code, I get that are not declared. I think that happens because Windows supports only 1.1 or 1.2, and because of that, Windows is only aware of a limited number of OpenGL functions. The other functions must be accessed via extensions, though. For some code, demonstrating VBOs do here. Oh. Yes, gen buffers is declared. Make sure the header file is included properly. Check your OBL version. Oh. Hey guys, what's the console command to see what my current OpenGL version is on my Windows machine? Include this. Include this. Ooh. Okay, so I need to include this. Does it work now? Cannot open file that. So I don't have this. So I need the extensions. That's what we're learning here, right? Okay, well, here's the deal, chat. I'm gonna go Riz, i.e. my girlfriend's making tacos. So, you know, I ain't skipping taco night, bitches. All right, listen, I like you guys a lot. But come on, man, I got tacos I gotta eat, all right? So here's the deal. I see a lot of new people here today, so let me explain the lowdown, okay? I stream every single day at 4:30 PM PDT-ish. Right now it's 7:09, so like 2.5 hours ago, okay? Normally I stream a little longer, but today's taco day, all right? You guys are awesome. Thank you for all the follows today. For those of you who came from the dinosaur sounding dude, or name, I should know his name, hold on. Hold on, everyone. Don't leave yet. I gotta know his name. Spyronodon. Oh, there. I'm a bee. My legs are under the table. Okay, they're folded. All right, everyone. Have a good night. Thank you, Spyronodon. Thank you for following. I appreciate it. I like it. Thank you. I stream every single day. Tomorrow, we're right back to OpenGL. We're going right back to drawing triangles and shit. We're gonna make a fucking video game, and we're gonna do this for class. All right, everyone. Have a good night. Have a good night. Give me goodbye. Like, ooh, chat. You taste good. See you guys tomorrow.